Hello and welcome to the Spent Grain session. Before we get going, I'd like to take a moment to acknowledge the contributions and the support from JCS Processing Control Systems.
My name is David Staccarosa, and I'm the Vice President of Sales and Marketing at JCS Processing Control Systems. Welcome to the second annual James B. Bean Institute Industry Conference. JCS is proud to be a sponsoring partner of the James B. Bean Institute and would like to recognize the importance of the University of Kentucky, the Institute for Kentucky Spirits, and the unique partnership it has with the bourbon industry. At JCS, we're honored to serve our customers with a full suite of engineered solutions for their front-end processing needs, including our exclusive Ultra Blend technology used in the spirits industry. The collaborative efforts of JCS and the University of Kentucky, we are so excited to be able to donate our very best Ultra Blend technology to the Institute for Kentucky Spirits. This pilot scale skid will be shipped in just a few short weeks and will serve both students and industry professionals alike throughout Kentucky and beyond. So please join me over the next few days in learning what's new and relevant in the bourbon world, as I will be looking for new and better ways to serve your industry. Thank you and enjoy the show.
All right, everyone. My name is Amanda Lefevre. I'm the Deputy Commissioner for the Kentucky Department for Environmental Protection, and thank you for joining us today on our Spent Grain session. With me today is Bradley Barron with the James B. Bean Institute. He's my partner in crime for this session, and we thank you for being here. This has become a really hot topic over the past few years, in case you haven't noticed. As this industry grows, and we're really happy that the bourbon industry is growing. It's an important key for Kentucky's economy. So if you're a bourbon lover, or appreciate all the trappings of bourbon, it's a great time for the industry. But unfortunately, there's a small wrinkle in that, there's stillage. For every gallon of bourbon produced, there's 10 gallons of this byproduct that we have to deal with. And by and large, most of the time that's dealt with in a very, very responsible manner. But the reason the Department for Environmental Protection has really honed in on this a little bit, in the past few years, we've seen some instances of stillage being maybe put into a creek, or maybe disposed of in a sinkhole. There might have been a spill at some sort of facility. So there's just things that have shown up on our radar that as this industry continues to grow and evolve, we know that the volume is going to increase. So that stillage is out there. And for those of you who are familiar, you know that one of the traditional ways that stillage has been reused is actually through agricultural purposes, for feed, for dairy cattle and things like that. But that industry unfortunately has declined. So we're starting to see some land application and things like that, which is fine, but it really can't be the end all be all. So back in December, our cabinet secretary charged us with, finding some proactive solutions for this. We know that regulation is not the end all be all for this. So we wanted to bring people together to talk about solutions for stillage. And at that point, we started talking with the Kentucky Distillers Association, the James B. Bean Institute, the Distillers Grains Technology Council, and we came together for a summit back in December to talk about spent grains, the technologies that are out there, and some of the solutions and things that are on the forefront, like agritech and things like that, and how we can bring all those things together and hopefully come up with some proactive solutions for this, because there's not going to be a one size fits all. We don't think. There might be a cornucopia of different things. So this event, this particular session is sort of the next phase of that. we're going to check in with you, and we're actually getting ready to launch some work groups to focus in on some of those areas that we identified back in December through not only the sessions, but through follow-up surveys. So we're continuing these conversations. And as we continue throughout 2021, we'll be reporting out at individual events, at the Distillers Grains Technology Council is having their session or their annual conference in Louisville in October. DEP has their Distillers Sustainable Spirit Summit also sometime in the fall. So we want to report out on that. So there's lots of ideas out there, reverse pitch with the economic development. So there's things out there that we're continuing to have this conversation. So with that being said, I'm hoping you'll enjoy today's session. There's some great information. And like I said, we're excited to have this conversation and continue to work with our partners to help solve the stillage puzzle. So with that, I'm going to hand it back over to Bradley.
Thank you, Amanda. Yeah, it's been a lot of fun to get going on that project, and we're all really excited to really find proactive ways to more or less change the economics of the stillage challenge. And a part of that sort of initiative and group that we've been working on recently really is our first speaker, Kurt Rosentrotter. He's been doing a lot of work with spent grains for a long time. I believe started out at the USDA looking at this problem, then eventually went over to Iowa State. Our first speaker is Kurt. I'm really excited to hear his updates for us. And yeah, with that, fire away.
Good afternoon, everybody. Thank you, Brad. Thank you, Amanda, for the introduction. I like how you put this. It's a puzzle. It's a cornucopia of solutions. I think there's a lot of interesting things that we can talk about related to stillage and potential applications. And so I've prepared a few slides and to share a few thoughts with you this afternoon. I've been working with this puzzle for quite some time. And, I think, somebody asked me several years ago, well, haven't you all done everything that needs to be done with distillers grains and distillers byproducts? And the answer is absolutely not. The industry continues to grow and the industry continues to have challenges. And so I think by convening the group today, and then the follow-on working groups, I think we're really going to try to help address some of these problems. So I'm coming to you today from Ames, Iowa. I work at Iowa State University, but I also work with the Distillers Grains Technology Council. And the council has been around since 1945, started by a couple of small distilleries, Seagram and Sons, and then Hiram Walker. So we've been kind of dealing with some of these questions and issues for a while. So what I'd like to do today is kind of give some perspective and maybe not completely offer solutions, but at least give some perspectives. And so I think what I'd like to do is talk especially about some of the economics and dewatering aspects, but we can't forget about some of our motivations as well. And we've got a lot of challenges. Every distillery is unique. Every company has different kinds of challenges. And so there's no one size fits all solution for everybody. So when we think about why we should care about this, why the industry should care, why the consumer should care, ultimately, I'm an engineer. So this is how I like to look at things. I like to look at things as black boxes with inputs and outputs. And historically, the use for stillage and stillage-based products, whether they're in dried or wet form, the majority of byproducts from distillery operations have gone into animals, either monogastrics or ruminants. Historically, it's been more ruminants than monogastrics, but that's been changing in the last decade. And so when we think about what goes into the animal and what goes out of the animal, the things that we control at the distillery, really, it's the feed ingredients. And so if by whatever process that you decide to implement at your distillery, if you are going to be sending these byproducts or co-products to animal feed uses, you've got to bear in mind that the livestock producers are going to be keenly aware of what it is they're getting from you, and they're going to be demanding a consistent product because that's ultimately going to impact their bottom line. So just to give you a perspective, currently in the US marketplace, the majority of distillers' products are coming from the biofuels industry, specifically the corn ethanol industry. So the corn ethanol industry has really sort of plateaued in terms of growth of production, but what we're experiencing in the beverage industry is exponential growth right now. And so I think it's important to understand that what we do in this industry really is mirroring what happened in the biofuels industry about a decade ago. And I think the livestock producers, if you're going to be producing livestock ingredients, are going to be aware of what kinds of products the ethanol industry is producing. And they're going to be, in some respects, very similar to the products that you might be producing. So historically, if we take a look at where do distillers' products go in the marketplace, beef and dairy cattle are the predominant users. And we can, because they're ruminants, they can use higher levels typically of distillers' grains. Generally speaking, the beef industry, it's common practice to use 40 or more % of distillers' products as 40% of the entire ration. Dairy cattle have historically been a little bit lower because of milk fat depression issues with some of the corn oil that's present in the distillers' grains, but that's changing now because many of the ethanol plants are removing oil. So the utilization rate in the dairy industry is growing. Swine and poultry, historically, the poultry's been significantly lower than the use in swine, but the swine producers have become very adept at using distillers' grains up to 40% or more of their rations. And so I think we've got a really interesting precedent set in the American livestock industry in terms of beef, dairy, swine, and poultry. So at the moment, approximately 1 ton of co-products, either wet or dry co-products, can replace about 1 to 1.2 tons of corn, soybean meal mixtures. And so that's something we need to bear in mind, because it's not quite, but almost a 1-to-1 replacement. And what are we replacing in the livestock diet, whether it's a beef, cattle, or swine or poultry? We're replacing either corn or soybean meal, or a combination of corn, soybean meal. So those are the two competitors that we really have to worry about. But in addition to that, I think if your company is going to be selling distillers' grains into the animal feed market, I think you also have to be aware that the fuel distillers' grains are also going to be a competitor to you. And so it's not just corn and soybean meal that we've got to worry about. We've got to worry about the other ethanol co-products that are in the marketplace as well. So, as you know, if only we lived in a perfect world and we put the grain into the distillery and out comes the alcohol. Well, unfortunately, we have to deal with the waste products or the byproducts. Or if we can actually capture value, we can't really call them waste or byproducts anymore. We're really talking about value added products. And so two sides of the same coin. If you are producing a livestock feed ingredient, or you're trying to sell your co-products into that market, we really have a balancing act, because we will be dependent on the livestock industry to help us because they are the market for our products, but they don't want to pay more than they have to. And vice versa, if you're going to be selling your co-products, you're going to want to obtain the highest price that you possibly can. And so there's going to be sort of a push-pull between the livestock industry and your distillery business. And it's not just a matter of demand, or it's not just a matter of price. We've got to think about availability, price, and I guess a third leg to this balancing tripod really would be consistency. So we have to have products that are going to be consistently available. We have to have a consistent, predictable price for our co-products, and we need to have consistent nutrient content. And we'll talk about that in a little while. So ultimately, if you are selling your co-products into the livestock industry as a feed ingredient, we're really talking about the long-term sustainability of both industries here. And so we can't talk about making alcohol without talking about a little stoichiometry, because ultimately it boils down to biochemistry. So if you put 1 kilogram of glucose into a fermenter, the maximum alcohol that you could get from that is about 0.51 kilograms of alcohol, and then the other approximate half is going to be carbon dioxide. But most of us are not putting pure glucose into our fermenters. Most of us are using some type of a grain basis, because that's our source of starch, our source of glucose. And when you start working with whole grains and you're trying to extract the glucose, utilize that, of course, we're not going to have complete conversion. We're going to have residual starch and glucose left over. We may have some of the secondary metabolites that are being produced, whether they're glycerol or fusels or higher or lower alcohols. And there's also that yeast cellular biomass that, all of this is consuming glucose and not producing ethanol. But hopefully you're all familiar with this idea of the rule of thirds. For every pound of corn that goes into your distillery, you're going to get about 1/3 of a pound of alcohol, 1/3 of a pound of CO2, and about 1/3 of a pound of non-fermentables, the co-products. So we could also do that on a kilogram basis too, 1/3, 1/3, and 1/3. So the idea is, what do we do with that last third? And some distilleries are doing a separation and then a drying to produce DDG or DDGS. Some are producing wet cake. Some are condensing their thin stillage into a syrup that they could potentially sell separately or add to their wet cake or their DDG. So it's important to understand that whatever form you're using the stillage right now, really, you've got a lot of nutrients in there. And this is why I think we have seen the livestock industry really use these materials as feed ingredients, because there's protein, there's fat, there's fiber, there's ash, there's a considerable amount of minerals. And so there's really a lot of value from that cereal grain that if you're just dumping down the drain for the city to deal with, or if you're potentially using this as fertilizer, you're not potentially capturing that full value in that grain kernel that you've purchased when you brought it into your plant. Now, every company is going to produce their ethanol or their alcohol a little bit differently. And then at the same time, every company is going to have some different compositions in terms of their whole stillage or their thin stillage or their wet cake or their dry DDG products. But that's one of the things that we have to consider. Whether you're talking about a whiskey or vodka distillery, or you're talking about an ethanol plant, there's a lot of commonality. A lot of the processes are going to be the same. The difference is going to be scale. And scale matters when it comes to break-even prices. And we're spending a lot of time talking about a traditional spirits distillery right now, but we could easily be talking about malt whiskeys as well, because the companies in Scotland and Ireland and Canada face similar questions that we're talking about today. But scale does matter, and economics are part of the story. So I want to spend a minute or two and talk about corn and soybean meal and DDGS, because those are the 3 competing products that you will potentially be competing with if you're going into the animal feed space. So I pulled these statistics yesterday to share with you. So these are updated in terms of the current price of corn. This is at the Port of New Orleans. We see that corn in terms of cents per bushel has really been, especially in the latter part of 2020 and early 2021, for a variety of reasons, really been considerably high. And I know that impacts your bottom line in terms of your raw ingredients coming into your distilleries, but this also is going to impact ultimately our competition for feed ingredients. So it's important to understand the stocks to use ratio as well. So that's been changing over the last several years, and some of that's due to droughts or floods or growing conditions, but part of it's also due to trade and some of the global economics that are happening, and the choices that farmers make when it comes to planting seasons. And so the carryover is not so great as it was a couple of years ago. And that may be something that plays a role in your choices. Historically, DDGS prices have been up and down. Several years ago, DDGS prices were pretty consistent at about $120 to $140 per ton for many years. But then China started to import DDGS, and then the markets really started to change. So they started to import, and then there were tariffs and trade bans, and now we've got COVID. And what you see in terms of, okay, we've got Chicago markets and New Orleans markets. These are the two that you see. They parallel each other pretty closely. But what we're seeing in 2020 really is due to impacts on the ethanol industry, primarily due to COVID. So it's important to understand what is the value of your product compared to corn, because distillers' products historically have been, their value has been compared to that of corn, even if you have a mixed mash bill. So what we see over the last couple of years, this ratio of the relative value of DDGS to corn, anything above the 100% line, this is a value to your distillery. If the value of the DDG relative to corn is below this dashed blue line, really, it's a benefit to the farmer. The DDG products are cheaper to use than corn or soybean meal. But what we see the last couple of years, we see quite a high level of the value of DDG. Almost 175% the value of corn. Now, is that because the protein's worth more? Well, it's because the value or the price for the DDG is higher. And like I said, really this year, the big driver's been COVID. So relative to soybean meal, what you're going to notice is over the last several years, DDG and other ethanol co-products really are of value to the farmer because they're 50 to 60% the value of soybean meal. So these are some things that we have to bear in mind. And I do want to talk briefly about the biofuel ethanol industry, just because the distillers' products that they're producing are ultimately going to end up going to similar markets to what you might be trying to sell your products into. So 2019, so this is million barrels per day of production. 2019 actually wasn't too bad a year. What we see in 2020, starting in March, and then slowly recovering into June, this crater, over 55% of the nation's ethanol plants were closed due to COVID. Either people were sick or the demand for the fuel was so low. But the industry sort of recovered throughout the year. And if you also remember a previous slide, I talked about the balance between price and availability. So we've got kind of a double whammy going on in terms of significantly high prices for distillers products, pushing $300 a metric ton. And then we also have lack of production. And so where are the livestock producers going to be getting their feed ingredients? So that's a challenge that we need to also think about. And then just a couple of weeks ago, we see about 45% of the ethanol plants briefly shut down throughout the country due to winter storms and cold weather, especially throughout southern states and northern states as well. So what happens in the ethanol industry, we really have to pay attention to, because they produce a large quantity of feed ingredients that are very similar to what we are talking about for our industry. So between 35 and 40 million metric tons of feed ingredients, typically the ethanol industry produces every year. So when we think about the competition and we think about what we're producing at our plants, and maybe some of you are producing wet cake for sale, or maybe some of you are producing dried distillers grains for sale, or maybe you're not. Maybe some of you are still taking your spent grains and letting the city deal with those. And it's definitely a cost to you, and every city is going to be different. And the rates change over time. I think it's important to understand, what is that surcharge going to be based on your COD and your BOD and your total solids, and every city is going to be different. But basically what we're talking about, if you're not capturing this value, you're really spending money that you don't necessarily need to, and instead of potentially gaining a profit. So when we're talking about taking that stillage, and let's start with the whole stillage, really, if we can reduce that solid load, if we can separate some of the solids, maybe not all the solids, but maybe some of the solids, that's potentially going to be a drastic cost savings for you in terms of what you send to the city for treatment. So now you could also ask the question, what do we do? What if I want to just send my spent grain, my whole stillage off to some of the local farms? It's expensive to ship water. It really is. And so if you're putting your stillage into a truck and it's 95% water, you're really not being cost effective in terms of your transportation. So what we're really talking about is sort of a double-edged sword, if you will. How can we reduce that solids load if we're going to be discharging water to the city? Number one, to save money for us, but also number two, to generate revenue if we can use these separated solids and send them to the livestock industry or to other industries. So you have to consider break-even points, and there are a lot of opportunities to separate these solids. So, if we were to make some assumptions, just to kind of show you some quick assumptions, if you were to do a large decanter centrifuge, that would cost at least $100,000. And depending on the price of what that wet spent grain would be, the distiller's wet grains, generally they range in price from $50 to $100 a ton. It's going to, in terms of how many tons would you have to sell to break even, you're talking between 1,000 and 2,000 metric tons. If you're talking about a separator technology that's $35,000 on the other hand, and there are a couple of options I'll talk about shortly, really you're talking about somewhere between 350 to 700 tons of production that you would have to do. So if we just briefly think about taking our whole stillage that's about 5% solids, I know it's going to be different depending on your distillery operations, but if we can dewater that to concentrate solids up to 50% moisture content, 50% solids, then really what we're talking about, how much do you have to produce to break even? In terms of gallons per week, it is much more feasible. We're really talking about payback in a year or less for many of the distillery operations that you might be working with. And there are a couple of options. Some I'm not going to be able to promote any specific companies, but there are some separators. Some of you may be familiar with this type of a centrifuge separator that works really well, and that's about between $25,000 and $35,000. There's another company that works really well, depending on the scale that you're operating, somewhere between $15,000 and $30,000. And some of these separators also have built-in dryers too. So it may not just be a matter of making wet cake to sell, but even a DDG. But these are just a couple of options. And I will say, I think the challenge is not in the separation. The challenge is in the marketing. And we spent a little time and talk about DDG from the ethanol industry being a competitor, corn and soybean meal being a competitor. The markets for distillers products are well developed, and they have been throughout the 20th century. So what we're really talking about is, what can you do that's unique? And maybe part of it is your mash bill, because you're not going to have specifically just corn like the ethanol industry has. So this is, I think, a great opportunity for many of you to be innovative and develop some specific ingredients that are not just the standard DDG. So I think with that, Bradley, am I out of time, or can I keep talking for a couple more hours?
I'm I mean, I'll save you so you can get to your class on time. But yeah, I think we're running a little long on time. So
Right.
yeah, close with a word or two. I think that'd be great.
Yeah, I think there's a lot of opportunities. The livestock industry isn't the only opportunity, but it is probably one of the low-hanging fruits in terms of ability to reduce your solids load that you're sending to the city and to develop a quick market for your products. And the further away the livestock industry is that you're trying to sell to, that really behooves you to consider what drying options you would have for the solids. So thank you for your attention today. I appreciate the chance to talk with you and look forward to talking with you all at a later point.
Thank you, Kurt. It's always a pleasure to hear from you, and I appreciate your perspective on all these things. For the sake of time, I want to push the questions over to the Q&A and give Kurt an opportunity to sort of feedback on that in free time. I know he's about to jump over to teach a class at Iowa State himself. So, but yeah, feel free to ask those questions, and the Q&A sessions for all of these sessions are staying live for a long time. So feel free to revisit topics that you've thought about overnight. All right, so for our next talk, pretty excited about hearing more about what's been going on sort of in the insects world and other opportunities associated with spent grains, and particularly wet spent grains. So I'm really excited to introduce Virginia Emery and Liz Koutsas, and we will let them tell us about what they've been working on recently.
Thank you for the invitation. This is a great opportunity for us to share a little bit about the insect world outside of the insect world. My name is Virginia Emery. I'm the founder and CEO of Beta Hatch. We're a mealworm producer based currently in Washington State, but actively expanding throughout North America. And I'm co-presenting with another key insects player here in the US.
Hi, I'm Liz Koutsas. I'm the president of EnviroFlight. We raise black soldier fly larvae. We have a commercial operation in Maysville, Kentucky, a pilot plant R&D center in Yellow Springs, Ohio, and an R&D and headquarters in Raleigh, North Carolina.
Yeah, so jumping right in, effectively, we're going to be talking a little bit today about what bugs like to eat. So if we look at how the insect industry has been evolving and sort of what insects do in nature, their best value and function is to mirror what they're doing in nature, which is being nature's biorecyclers and the foundation of most food chains. So they are digestive powerhouses. A great example is the digestion of polystyrene, also known as styrofoam. The only known way to biodegrade styrofoam is in the gut of a mealworm. So it just gives you an idea of the kinds of things these insects can be breaking down. And both mealworms and black soldier fly can break down mycotoxins, which are sometimes of large concern, especially in the distiller's realm, where some of these toxins can get concentrated by fermentation. As animal feed, that's one of the largest market opportunities for insects. Natural animals are eating insects, and that's one of the big drivers for the development of the industry. And that's because there's value beyond just nutrition. We see things like improved animal health, improved feed conversions in animals when insects are incorporated into the diet. And so some really exciting opportunities being developed globally within this industry. And the main products, this is a picture of our dried insects. The black soldier flies are a little kind of more fatter and squat, but look very similar as a whole insect. This is an animal feed ingredient, typically in the pet, aquaculture, and poultry markets, a high protein, high fat ingredient. And we also produce a byproduct or co-product called frass, the insect manure, which has value in animal feed markets, but also in soil applications as a fertilizer, soil amendment, and biostimulant. So the two bugs we're talking about today are being developed. There's sort of really only two main insects currently being mass produced for agriculture. There are others being developed for food markets or other applications, but the big players are the mealworm and black soldier fly. We'll speak each to our special bug in turn, but so there are some differences between these two. The main ones are that the mealworm and black soldier fly have different diet requirements. Mealworm's base feed, which is most of what we put in the system, is typically more dry, but we supplement with a wet feedstock. and the black soldier fly likes to have a moist base feed. And so those are some of the big highlights, as well as just the carbohydrate, fiber, fat, and protein contents being slightly different nutritionally for these animals. But because we have this controlled environment production, we have year-round bioconversion, which matches really nicely with a lot of the food systems we have, which are also year-round. And so I think there's a really exciting opportunity here. I'll speak to the mealworm specifically. This is a type of beetle, also known as the darkling beetle. They lay eggs, which will hatch into the larval stage, which is the main product that we harvest, is the larva, the mealworm. And then a subset we allow to continue to develop into the pupal stage, which is sort of like the cocoon stage here of this insect, and the cycle continues. And historically, as a stored grain pest, this insect can eat a wide range of things, typically higher in carbohydrate and fiber content, and generally prefers that drier diet. But as I'll show you, I think there's some interesting applications for some wet feedstocks as well. So Beta Hatch has been working for several years on developing new feedstocks for our insects. We have funding from a variety of different agencies to be working on this question. And you can see here, this is a picture of frass collected from some of our feeding trials. What you put in changes what you get out. And so you can see just this big range of colors. We've been doing some fun, it's effectively a sandy type product. So we do some fun sand art sometimes as you get these different outputs. But we've looked at over 100 different ingredients with a special focus on some of these distillers products. And one of the really valuable things that we've been exploring is also their ability to break down, as I said, these mycotoxins, residues left behind by fungi and microbes that can have not just chronic health effects, but lethal effects in animals and humans. And so our insects and the black soldier fly as well can break down these toxins in a way that allows us to take in feedstocks that other animals or livestock may not be able to use. So really interesting opportunity there. How do we know what the bugs like to eat? So we've published a paper with a collaborator at the USDA on some work we've done in just figuring out what it is that bugs like to eat. We've effectively asked them to tell us with these cafeteria style experiments. And so these have to be done in a very intentional way. You have to make sure the ingredients are prepared equivalently so that you don't end up, artificially measuring whether they like a certain granule size of feedstock, for example. But by preparing those diet ingredients and then putting them in an arena, we can then see what the insects themselves choose to eat. And so this is just one of many different studies that need to be undertaken because we know very little about insect nutrition compared to a lot of other animals. And so from this, we've been able to sort of pinpoint what the mealworms choose to eat if they have a choice, what their preferences are. And so these are just some different trial arenas that all kind of converge on this high carbohydrate, low fat, sort of low protein type of profile. And you can see across some of these different combinations, we end up with different feed metrics. And so you can see how much food they ate, how much live biomass they gained, and how efficient were they at converting that food into biomass. And they don't always know what's best for them. You can see this example, the blue square shows one of these diets where those animals were effectively choosing something, the potato chips, if you will, that were not as healthy for them. So this is just one of many tools to assess that insect nutritional need. This is some other work that we've done looking at more commercially relevant densities and conditions, and we've replicated this at even larger scales. But trying to look at, this was focused on a corn DDG product that, different inclusion rates, and did a great job of outlining the percent of some of these ingredients in other livestock. You can see we can actually get very high inclusion rates with insects, which makes us sort of uniquely positioned to potentially create some opportunities for producers of these ingredients. And so that has value for us on both a cost and nutritional basis. And one of the interesting things, and I think an area we'd like to explore a little more, is this application of a wet feed. So as I mentioned, mealworms are on this dry base diet, but when we apply a wet feed, you can see when there's no wet feed, the diet, just the dry ingredients, they're not performing as well as when we add a wet ingredient to the diet. And just with that addition of a wet feed, we can make what is otherwise, one of the poorest performing blends actually become on par with some of the higher performing blends. So this is an opportunity for an application not just of a dried distiller's product, but also of a wet distiller's product to our insects in a way that could ultimately result in sort of a win-win of some great applications for producers within this industry of in the distillery market, but also for insect producers like ourselves. With that, I'll turn it over to Liz for the next piece of what we're going to talk about.
Thanks, Virginia. And so I just want to expand upon some of the things that we've touched on, and what Kurt touched on is this, this application of ingredients to livestock production. And I think the insect producers fit very well in that category. And as we look at the evolution of the insect industry, we know that we are creating novel ingredients and alternative ingredients to help supplement the needs to feed animals, to feed the growing population. It also allows us to provide ingredients and nutrients to animals that maybe are more appropriate or more sustainable, or can utilize things like Virginia mentioned, high mycotoxin contaminated grains that may otherwise not have an opportunity to be used in the animal feed chain. Next slide, please. So the species that we work with is a black soldier fly larva. Similarly to the mealworm, we have an adult life stage, which is the fly. The adult fly lives about 7 days. It doesn't eat during that time. It lives to breed. And the neat thing about this animal is that it is native to all continents except Antarctica. So it's lovely because it's not considered an invasive species as we look to expand facilities. If you have a compost pile in the Kentucky region, you will probably seen this animal. And that fly lays eggs, and those eggs hatch in 3 or 4 days. And then over the course of 18 to 30 days, they become larvae that are market age or harvestable. About 5% of that population goes back into becoming broodstock. So again, very similar to the mealworm story and very similar to other livestock production systems. We also produce whole dried larvae, and from that you can extract the high protein meal, the oil, and then our biomass. Soldier fly larva is very omnivorous, and so like the mealworm can eat a wide range of ingredients, and we have also focused extensively on examining lots of pre-consumer food waste from food and feed industries. Next slide, please. The black soldier fly does have an AAFCO approval, meaning we are able to sell it as an ingredient into the animal feed industry. Currently, it's approved for pigs, poultry, and salmon, with dogs in process. This is specific for the whole dried larva, and it's partially defatted high protein meal. And I've highlighted here one really important component of the definition that by which we can sell the ingredient into the animal feed industry. And that is that it must have been raised on a feedstock that is approved. Essentially, it's a feed grade material. So it's a really critical component of our business, and any insect producer, frankly, in the US is going to be looking at that kind of situation in the near term. So for example, we can't feed manure to these animals and create an ingredient that goes into the animal feed markets. That may come in the future, but right now we really focus on feed grade materials. Next slide, please. And the beauty of it is there's a lot of food and feed waste that we can use, because essentially almost everything that goes into the human diet would be considered acceptable as an ingredient in our animals in the black soldier fly larva diet. And the tremendous amount of food waste is something that we can access and use to upcycle into high value nutrients. Next slide. So in our research setting, this is how we examine a new feedstock, and I'll give you some specific details around some of the distillery co-products. But our first step is looking at regulatory. So as I mentioned, we have to have approval of the ingredient as a feed ingredient or a human food ingredient. And then we look to see if it's safe. So we've mentioned the mycotoxin decontamination. That's all well and good. If we know something's coming in with mycotoxins, we have to obviously make sure that the back end is clean, that the larvae have done their job and completely detoxified it, so that we're not putting something back out that still has a contaminant. The second item that we look at is the consistency of that raw material. So is there seasonality in production? So if we built a system around it, would we need to worry about what happens during the summer when a system gets shut down, or during the winter when it's not being harvested? And then variability, and I think Kurt talked to this a little bit, the variability from but we need to have a pretty clear understanding of how variable an ingredient will be. If you kind of pass all of those tests, then we go look at performance, and that's how the larvae perform, and then the composition of the finished products, because of course we are creating an ingredient for the animal feed industry, and it's really important that we have safe, consistent products that we can provide our customers. Next slide. So some of the ingredients that we've examined in our systems are distillers' wet grains, which are the numbers that are listed are the AFCO approval numbers. We looked at condensed distiller solubles, and we've looked at dry DDGs and distiller dried grains. We've also looked at the stillage, which would fall probably under the wet grains approval category. So essentially, most of the co-products that are coming out of the distilleries are already approved, which is great. We do understand there's some seasonality, and that's certainly dependent on the distillery. And then moderate nutrient variation. And I listed here just the moisture, but we also track protein, fat, fiber, micronutrients, et cetera, to understand how variable that might be in our system. Here in the next slide, I can share a little performance data. So this represents some data from one single distillery in Kentucky where we examined dry DDGs, and we actually use dry DDGs in our standard commercial diet. And then we compared that to condensed solubles, whole stillage, and thin stillage at various inclusion rates. And the bottom line is we got very consistent performance of our animals. On the left side graph, you see the survival of the animals was relatively consistent. And on the right side, the growth of those animals, obviously very exciting data that when we use particularly the stillage and applied that to our feeding program, we actually got improved performance of the animals. And as Virginia mentioned at the beginning, the black soldier fly larvae really like a high moisture environment. So we believe adding not only the water component, but those nutrients that remain in the stillage kind of give those larvae a little extra performance enhancement. And additionally, we again check the nutrient composition of our finished products. And with all of those ingredients, we were able to maintain the nutrients of our ingredients within our specifications. So this is all really exciting, and what these kinds of data do, and as we, in Virginia's group, as we examine ingredients for applications to our specific manufacturing and production processes, these kinds of data allow us to then have those next conversations about real applications in commercial settings of these kinds of raw materials. So I think in both cases, the mealworm and the black soldier fly larva provide an incredible opportunity to upcycle distillery co-products. As Virginia mentioned, and our data show, we can use quite high inclusion levels of these byproducts. And I know our animals are much smaller than cattle, but we have trillions of them in very, very small areas. I think we do have to recognize, and Kurt mentioned, the need for dewatering for specific applications, and frankly for logistics. When we're talking about transporting something that's 95% water, that gets quite expensive if you have to go very far. And from our perspective, having a very clear understanding of variation in seasonality and volume and nutrient composition is really critical to us evaluating applications in a commercial setting. Virginia?
Yeah, I'll just add that you can contact either of us. Our emails are right there. We're very keen to discuss potential collaborations with the industry and find ways to, I guess, develop some new products and new uses for different co-products coming out of the distillation process. And I think just sort of a shout out to the cyclical nature of what I think the whole industry is moving towards, which is closing a lot of these loops and trying to keep nutrients in the system, reduce that waste problem. And I think there's a really exciting opportunity here.
Yeah, that was an awesome talk, and I'm really excited to see where this technology is going. Could you comment, and maybe I missed it when you were talking, maybe on the economics of this process in terms of value add, in terms of, is there a way to basically upgrade stillage type materials?
Liz, do you want to take that?
Sure. So I think in our system, obviously, as I said, we use dry DDGs from the bourbon industry in our current production diet. So, we're subjected to the graphs that Kurt showed in terms of pricing. As we evaluate some of the higher moisture ingredients that obviously would cost a distillery money to further dewater or dry, I think we do apply those economic assessments to say, is there a shadow price that we could apply that, say, a press cake would add value to our system at maybe a lower cost to the producer? I think for the really high moisture items, I have a hard time finding a situation where there's not going to be a cost to the producer, because frankly, the logistics of moving water is costly to whomever is dealing with that. The press cake to me is really exciting, where you've partially dewatered it, so it makes it more economical to move it, and maybe you can go a little further and still have value. So I would say in our economics, broad strokes, the wet stillage probably still has some cost to the distillery. The press cake may end up being cost neutral, and I'd love to see the economics on the actual dewatering and drying process to help. We want to be in a win-win situation with our ingredient suppliers. So I think there's probably some opportunity in that product stream.
Yeah. And I would say that the ability to also secure sort of longer term commitments from distillers really plays into the economics as well. So we recognize there's going to be fluctuations in these markets. So if we're able to contract for longer term supply agreements, that allows us to potentially, you win some years, you lose some other years, but on the balance, ideally it's an opportunity that works for everyone. So thinking about the length of a supply agreement could impact the economics too.
Yeah, great. So there's some other questions. So getting into the different types of materials that you'd be bringing in. So if people aren't familiar with the different stillage streams, you typically start with whole stillage, which is just that 95% water stream coming out of the back of the still, and then you can basically, to some extent, filter that. So that wet cake is what you guys were talking about, is that sort of thick stillage, that concentrated solids. Usually I think on the order of like 35% solids in there. And then all that liquid that's left is that thin stillage, everything that drains out of there. So specifically on that thin stillage, can you discharge the liquid coming out of that thin stillage? Is there a disposal issue associated with that?
So in the case of the black soldier fly larva, they become the system of purification. So they take that water, they take the water fraction and they end up putting it in the larva. So our live larva at harvest are about 62% moisture. So they're taking the water, and there is evaporative losses that come out of our system. They obviously respire and put moisture into the air, but that's clean water that has no permitting requirements. That's not something that requires a sanitary line or anything like that.
Yeah, and I would add both of these insects are animals, and just like us, human beings are about 60% water. So we also have dewatering as part of our processes to create a final product. So that plays a little bit into this use of water in the diet. I think that for some, this is not a silver bullet solution for everything. I do think there's other fermentation uses, as we've seen with like the manure industry and how they've developed some solutions for very liquid inputs. That again, thinking about co-location is probably pretty key. The shorter distances these materials have to travel, certainly the more beneficial it is for everyone.
Yeah, great points. Well, thank you very much for coming out and speaking with us today. And I'm really looking forward to what's coming down the pipeline on this one. So thank you both.
Thank you.
Thank you.
Yeah. So for our next talk in the spent grains, where we're going to look at other sort of emerging technology in the spent grains utilization space, and we've got two representatives from Somax Bioenergy, Dan Sprackland and Jeremy Taylor, and I will turn it over to them to share with you.
Thanks, Brad. And thank you to the Jim Beam Institute and to the sponsor JCS for allowing this opportunity to speak with you today. My name is Dan Sprackland. I'm here with Jeremy Taylor. Jeremy will be in the chat answering questions, so feel free to fire away. He'll respond to them in real time. And we are Somax. It's Circular Solutions, presenting circular solutions for spent grains. We are a startup company. We have accomplished quite a bit in a short period of time. We've completed 6 years of research with Villanova University School of Sustainable Engineering. We've published 8 master theses and established 4 international partnerships. We completed our first pilot plant in Chur, Switzerland in 2018. That was our 3rd generation reactor. In 2019, we were awarded the first design build for a wastewater treatment plant in North America. And also we were a finalist for the manure challenge, where we turned dairy manure into activated carbon. And finally, this year we were awarded the finalist for the Department of Energy's Resource Recovery Prize, that's seeking scalable, repeatable solutions for implementations at wastewater treatment plants across America. So today I want to talk to you a little bit about the resource recovery platform. This is a platform that turns one-way flow of materials into a circular flow of revenues and savings. So this really plays within the water, nutrient, energy nexus. We're able to take spent grains, reuse them to create low carbon heat, as well as recover nutrients and water from those spent grains, turning what is typically a liability into an asset. And the heart of our platform is a process called hydrothermal carbonization. It's a novel approach to transform organic waste into technical carbons. What we do, the easiest way to think about it is an industrial sized pressure cooker. We heat up the material, so it is a thermal process. We heat it up to around 400 degrees Fahrenheit, so what you would bake a frozen pizza at or make cookies in your own oven. With that pressure is at 300 PSI. The retention time is anywhere from 30 minutes to 4 hours. With spent grains, we're talking about typically around a 30-minute cycle with a carbon efficiency of 90 to 95%. Up top, you'll see these circles. These are the chemical reactions that occur with increasing severity of the transactions, of the composition of the severity of the reaction temperatures or parameters. So on the left-hand side, you'll see our 2nd generation reactor, and then on the right is our 2018 3rd generation reactor. So these are the size of shipping containers. We have a small compact footprint. This reactor will actually process 15,000 tons per year at around 10-15% dry content. So we like wet stuff. What we do is this pressure actually turns water into a catalyst, and it breaks down these compounds into more easily consumable products. So things like lignin, we break that down. Hemicellulose, we break it down into carbon, nitrogen, phosphorus, so on and so forth. Really at a high level, this is the baseline products of HTC. You'd put in your spent grains, goes through the hydrothermal carbonization process. Then we have actually mechanically dewater process that we use, that those solids come out at greater than 50%. We've achieved 60 to 70% dry matter without the use of any polymers through this mechanical dewatering device. That's the solid phase. That can be either used directly, dried and used directly as renewable energy. It could be used as a soil amendment for sequestering carbon in soils. Also can be upgraded into things like technical carbon, so activated carbon and things with high value. On the liquid side, you have coming out of the press, you have a biosolution. It's rich in nutrients. Anything that's non-soluble or anything that's soluble within the spent grains will actually go into the liquid fraction of this process. That can be used as a liquid fertilizer. It can be refined and filtered and created to clean water that can be potentially discharged directly into a stream, or we can actually extract out nutrients in it. So ammonia sulfate is a fertilizer. It's a nitrogen-based fertilizer that we could extract out of the liquid processed water. Looking in a little bit more detail on what we can do. So this is kind of a high-level flow diagram of your mash. You have your spent grains. Again, we go through an initial dewatering step because spent grains are coming out 95, 91% water. We want to get them to about 85% moisture content. And really that's just to maximize the real estate within the reactor to make it more efficient. So through the dewatering step, we go through advanced filtration. We can get clean water. That goes into our hopper, goes into the HTC process. Then we buffer it and depressurize it. So this is a 24/7, 365 continuous process. We run with, morning, noon, and night. Once we're able to do that, we can mechanically dewater this material to create the bio-rich solution. And again, the solid content for biocoal. That biocoal can go into a dryer, and then it can be pelletized and stored, and it can be used for gasification and cogeneration. So you can make renewable, carbon neutral electricity and thermal energy from your distiller's grains. So we know some distillers have gone through and looked at anaerobic digestion. If you've already gone down that route, that's great. We can actually implement and enhance that process. So this is research that's hot off the presses. It was released in December of 2020. And the use of that process water or biosolution can be sent directly to anaerobic digestion, and it increases biomethane potential anywhere from 30 to 300%. So it increases the amount of methane that you can produce off that same material by 30 or 300%. And the way that it does that is how you actually integrate HTC and anaerobic digestion. So in this first scenario, where you get about 30% increase in biomethane production, you actually put it through AD first, dewater it, put it in through HTC, and that process water or biosolution goes back to anaerobic digestion, generating an additional 30% of biogas. The reason for that is we've broken down those heavy lignin structures and made them bioavailable to the bacteria to produce that biomethane gas. And then finally, the solids there can again be gasified for thermal and electrical energy. The second scenario where you can approach 300% increase of biomethane is by doing HTC first, then putting everything, including the solids, through to the anaerobic digestion. Then you actually implement the dewatering step and then gasify for thermal or electrical energy. So we set up with our partners, JCS, and we kind of went through and created a case study for a Kentucky distillery with the goal of maximizing thermal energy. So a little bit of basics. This distillery produces over 100,000 gallons of spent grains a day at 91% moisture content. They don't have any anaerobic digestion. So what we did is we proposed implementing this solution. What would it look like? What would the impacts be? They're pretty significant. So the impacts are we create a little over 120,000 MMBTUs per year, displacing natural gas use. This alone, replacement, reduces the carbon footprint or CO2 emissions of that distillery by 5,000 tons, roughly 60% reduction in CO2 footprint. In addition, this removes or reduces their hauling by 70%. We've had a couple presenters talking about how hauling water is very expensive. We can eliminate that hauling altogether. This removes, 13 truckloads daily, or reduces the trucking or hauling by over 70%, while producing over 60,000 gallons of clean water every day. In addition to that, the big winner here is that this would save this Kentucky distillery over $2 million a year in disposal costs of spent grains and in energy production, creating that closed loop system. So, energy is really the low-hanging fruit for us. It's easy to create energy out of this, but with a nice clean feedstocks like spent grains, we're able to do a lot more. There is studies out of the University of Kentucky where they've done this at the lab scale. They've taken spent grains and turned them into supercapacitors. Our partners are actually working with a German university and working on spent brewers grains to create sodium ion batteries for energy storage. In addition to that, we're working on some advanced applications like carbon nanotubes. So it's very interesting, very large amount of products that can be created from this quote unquote byproduct or waste material. And we're really just scratching the surface, but really what we're doing is closing that loop. With the size of our reactors being a small footprint, they can actually be co-located on site with the distillery. So there's no logistics that have to happen. There's no hauling out or hauling in. Everything can be handled on site, and we close that loop. So you have the benefit of saving money, lowering your carbon footprint, and becoming more sustainable and creating more sustainability for your brand. So I know I went through that fast because we were pushed for time. And so I guess I'll open it up for questions. Here's how you can get a hold of us at somexhtc.com, or you can email me at dan@somexhtc.com.
Great, Dan. Thank you. So while we sort of look for some other questions to roll in, my first question was on the clean water being produced. Do you have stats or specs on the water production out of that, or did I possibly miss that?
So it's 60,000 gallons a day that's being produced, and it's being, it depends on actually what the distillery would want, whether you want to take it to stream discharge or whether you want to use it for a fertilizer that could be sold into the marketplace or sold to your suppliers.
Okay, yeah, I was more thinking of that worst case scenario. So if you didn't clean it up through like RO or anything like that, if you're basically just looking what that discharge stream of that water would be, do you have the like COD, BOD, or specs on what that water would be?
Not at the moment, because a lot of it depends specifically on the blends and on the mash bill that's being used. So there's not really one that you can give specific. But what we do, it depends on, again, if you incorporate this in anaerobic digestion, AD lowers the COD and the BOD content as well. And then that processed water can be discharged either in sanitary sewer or could be put through RO, for example, and discharged to the stream.
Yeah, sounds good. Or maybe throw it in some insects. We don't know.
Yeah, throw it in some enzymes, because there's actually a new study that just came out that if you leave the water alone for a week, it self-accumulates carbon nanospheres that are used for actually supercapacitors. And you don't have to do anything. The products just self-assemble through the settling process, essentially, of that processed water.
Yeah, and then very last question, how much input energy is required on the system? I know that you're looking at the net positive energy. Is there something required to be put in at the front end?
So really just through priming the pump to start the process. So we would need some natural gas use or some propane use or even electricity use to prime the process. But the real benefit is that we produce roughly 10x the energy that we consume. So once we're up and running, we are actually self-sustaining. So we require no energy input once we're up and running. We will require some for startup, get everything going, get the process going, priming that pump, if you will. And then we're able to, run independently of the grid and produce, in this case, we produced enough thermal energy to meet 75% of that distillery's energy demand.
Fantastic. Well, Dan, thank you very much for sharing that with us and for taking our questions. If people have additional questions, please hit up the Q&A, and I'm sure Dan and Jeremy will keep an eye on that throughout the day. On behalf of Amanda and myself, I really appreciate you guys joining us for this session. Next session's coming up, looking at distillery finances. Sam Rock's putting that together, and I'm really excited because he's been in that world a while, and I'm excited to see how that goes. So please join us in a few minutes for the distillery finances session. Thank you all.